Hello, I'm Patty Simpson with Simpson Math. Let's look at some combinatorics examples. So in all three of these questions, it asks us at the end how many different ways or how many different things can we have. When we have that question of how many different ways, we know that we're looking at a counting or a combinatorics problem. And we know we have three different methods for solving the problem: fundamental counting principle, permutation, or combination. So we need to decide which we're going to use and then solve it. Here's our first one. A mechanic has a list of 10 customers, but only has time to work on 4 cars. How many different ways could the mechanic choose the 4 cars? So we have a group of 10 cars and we're going to choose 4 of them. When we have a group and we're choosing some, we know that's either a permutation or a combination. So then we ask ourselves, does the order matter? Do we care if we're the 4th one on the list or if we're the first one on the list? As long as we're on the list to get our car fixed, that's all that matters. So order here doesn't matter. We just want our car fixed. So this is a combination. So we're going to work with the combination formula where we have a combination, we have a total of 10 cars, and we're choosing 4 of them. We can also write that with this notation where we have 10 choose 4. This is just another notation for combination. It's only for combination, but this is another way to write 10 choose 4. Notice there is not a vinculum. It's not a fraction. It's just another notation that lets us know this is a combination. That's 10 choose 4. Then we're just going to use our combination formula where we put the 10 on top, factorial, over 10 minus 4, factorial on bottom. And since it's a combination, it also has the 4 factorial on bottom. Now we simplify. Let's start inside the parentheses. So inside the parentheses first, 10 minus 4 gives me 6 factorial. And then on top, I have 10 factorial. Remember, I can't multiply this until I take care of the factorial. That factorial is an operation I have to take care of next. So I have on top, 10 times 9 times 8. Now I want to stop at the larger of these two numbers so that I can simplify and cancel those two out. So I'm going to stop at this 6 factorial. I could count it down, 6 times 5 times 4 times 3 times 2 times 1, or I can just stop it at that 6 factorial and know that this 6 factorial and that 6 factorial are going to become 1. This 4 factorial, though, is not going to cancel out, so I need to multiply it so that it's 4 times that exclamation mark means it's 4 times 3 times 2 times 1. Make sure to count that one down. It is true, though, that we should, every single time we have a combination, be able to cancel out everything in the denominator. So this should divide into everything on top. Let's see if we can figure that out. So 4 goes into 8 2 times. 3 goes into 9 3 times. This 2 could go into the 10, or it could go into that 2, whichever one you like best. I'll do it into that 2. So notice that 4 times 2 made 8, so it just canceled out that 8. So then I'm left with 10 times 3 times 7. But maybe you were left with, this 2 went into the 10 5 times, so maybe you had 5 times 3 times 2 times 7. We'll end up with the same answer either way. Now I just multiply. 3 times 7 is 21, times 10 is 210. So there are 210 different ways that he could group those 4 cars out of the 10 to put on his list to fix the cars with. Here's another example. A mechanic hosts a car show and 10 cars enter. how many different ways could the mechanic give first, second, third, and fourth places? Again, we have 10 cars that we're going to choose 4 from. So this is another either permutation or combination. Then we just ask ourselves, does order matter? Well, in this case, getting a first place or a second place are different. These have different places to them, different arrangements, or each position has a different title to it. So the order here does matter. So this is a permutation. And for permutation, we say 10, it's still choosing 4. So here we have our permutation of 10 and 4. So again, I have 10 factorial on top, but on bottom, I just have the 10 minus 4 factorial. We don't add the other 4 factorial there. Now I just multiply it out. This is 6 factorial on the bottom and 10 factorial on top. So I'm going to count down to 6. 10 times 9 times 8 times 7 times 6 factorial. This 6 factorial and that 6 factorial become 1. I have a little more math to do this time. I have 10 times 9, which is 90, and 8 times 7, which is 56. So there's a 0 on the end. 9 times 6 is 54, carrier 5. 9 times 5 is 45, plus that 5 makes 50. So there are 5,040 different ways that the mechanic could choose those 4 cars to give places to. Last one. A mechanic is fixing a car that has an alarm. The alarm has 10 up-down switches that make the alarm. How many different alarm codes can be made? This time we don't have a group of 10 cars that we're choosing a few cars from, nor do we have a group of alarms that we're choosing a few from. Instead, we have independent events happening here. We have these up-down switches that make the alarm. So picture what's happening. If you can have 1 up and 9 down, and that's one alarm. Or you can have 1 down and 9 up, and that's a different alarm. Or you could have an up, down, up, down, up, down, up, down, and that's a different code for the alarm. And we want to know how many different codes are there. So each one of those switches is an independent event that's occurring. So we need to ask ourselves, how many choices are there for each of those independent events? Well, the first switch has 2 outcomes, on and off, or up and down. So the first switch has 2, the second switch has 2, the third switch has 2, and we're really doing that for 10 different switches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one of the up-down switches is its own little event that's independent from the others, and we're just looking at how many outcomes there are for each of those events. Now we do a little multiplication. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, 64 times 2, 64 times 2 is 128, 128 times 2 is 16, carrier 1, 4, 5, 256. Let's do this times 4, these guys, and let's make that last bit times 4. So 256 times 4, well, 4 times 6 is 24, carrier 2. 4 times 5 is 20, with the 2 carried is 22, carrier 2. 4 times 2 is 8, 9, 10. So there are 1,024 different ways that we could set that car alarm. So this is how we deal with our combinatorics. When we ask how many different ways, we're looking for those 3 options. If we have a big group we're choosing some from, it's combination, permutation. Ask yourself, does order matter? If you don't have a big group that you're choosing a few from, look for the number of choices there are for each one of the events and use that fundamental counting principle. Math made simple, it's Simpson Math. Thanks for watching.